Alright, trying this a second time. Today we're talking about solving systems of equations using substitution method. We've been talking lately in class about a system of equations being just a group of equations, all using the same variable, whose solution is when the values of the variables work for all the equations at once. We're talking how graphically, since we're doing lines right now, it's where the lines intersect. And in fact, we've also mentioned that that works for bigger and crazier systems where instead of lines you have curves and shapes like circles. Where those intersect would be the solutions. But for now we're just dealing with lines. On these linear equations, algebraically, there's two main ways of doing this. First one is what's called the substitution method. I'm going to go through and just kind of outline what happens. You might want to take notes, use the pause button if you need to, and then I'll go through some examples showing step by step how each of those things are used. So here we go. Here's the big idea. You're going to look at your equations. You're going to look for a variable that is going to be easy to get by itself. Like if you had x plus 3y equals something. It's really easy to subtract that 3y over and get x by itself. Or if you have 5x plus y equals whatever, you can subtract that 5x and get y by itself. Maybe you have a 2x, for example, and all the other numbers in that equation are even. So you can get the x by itself, because when you divide by 2, you're just going to get whole numbers. You don't have to worry about any fractions. Okay. Now, once you've picked that equation for those reasons, you're going to get that variable by itself. And again, if it's just a plain x or a plain y, that should be really straightforward. And sometimes you have to divide. Try not to get fractions when you divide. All right, now, at this point, you have either x or y, whatever letter, equals stuff. That stuff is a value for that variable. You're going to take that value, all the stuff that's now on the right of the equal sign, and substitute it in for that variable in the other equation. That is important enough. I'm going to underline, try to underline the word other. It has to go in the other equation. If you plug what you just did into the equation you started with, bad things are going to happen. We don't want bad things. Now, once you do that substitution step, you'll have an equation with only one variable in it. You can solve that. You've been doing it for a while. So, solve it. Get whatever your variable equals. And then you're going to take that value and put it into one of the original equations before you've done anything else with it and figure out what the other variable equals. That step is called back substituting. You're taking a value you found at one point in your problem and putting it into an equation from earlier in the problem to get a different value. Alright, so I just kind of talked through it. So now I'm going to switch over and do an example. So firing up the tablet. So I have the system. The equation is 4x plus 3y equals 4. 2x minus y equals 7. Right here, that y is going to be fairly easy to get by itself. So I'm going to start with the second equation. I'm going to subtract the 2x from both sides. Now I have that negative, so I just need to divide everything by -1. That gives me a positive 2x minus 7. So y equals that guy right there. Now I'm going to take, now that's so that's the first two steps. Switch to red. I'm going to take this first equation, the other one, not the one I used, and I am going to replace y with what I just figured it out to be. Now look, this is this it's not coming up now. My pointer's not. What I just wrote, the 4x plus 3, quantity, all that, is this first equation. But instead of putting in y, I put in 2x minus 7 that I figured out y equals. This equation now only has x's in it. So I can solve this. Distributive property. Add my like terms. I'm going to add that 21 over. Divide by 10. X is 2.5. Now, switch to green. I'm going to take this value that I just found for x. I'm going to put it in either of the original equations. I think I'm going to put it in this one just because why not? Now notice how I'm taking this value, this 2.5, and bringing it all the way back up to one of my original equations. That's the back substituting. So I'm plugging 2.5 in for x. 5 minus y equals 7. Subtract 5. Y equals negative 2. I could have also, by the way, plugged it in there, and that would have saved me a few steps. Still would have gotten negative 2. So my answer, 2.5, comma, negative 2. Oops. Negative 2. All right, let's try another one. Gotta keep these color coded. So blue is my first couple steps. So I'm looking at my two equations. 2x minus 3y equals 6. And x plus y equals negative 12. And let's see here. Looks like both my x and my y in the second equation will be pretty easy to get by themselves. Let's this time go with that x. So that's what I'm going to try to get by itself. So here's that second equation. Subtract y from both sides. X equals negative y minus 12. Beautiful. So there's a value for x. I'm going to take the other equation, the one I didn't use, and I'm going to replace x with that. 2 parentheses. So this is the x I'm replacing. Negative y minus 12. Closing parentheses, minus 3y equals 6. This equation has one variable in it, y. So, distributive property. Collect my like terms, negative 2y, negative 3y, negative 5y. Add the 24 to the other side. Gives me 30. Divide by negative 5 equals negative 6. So I know that the y that works for both equations is negative 6. So I'm going to take the negative 6 and I'm going to plug it into this equation right here. I could have plugged it into the original equations, it would work just fine. x equals negative 6 minus 12. Be careful of the double negatives. Negative, negative, negative 6 in for y. X equals negative 6 is positive 6. Minus 12 equals negative 6. Negative 6 for x, negative 6 for y. There's my answer. One more time. I'll give you a little pause here. Look those over. Which equation are we going to solve for which variable? If I were doing this, which I am about to, that's the equation I would pick. This is the variable. It's just a plain old negative y, so we don't have to worry about anything there. I subtracted the 3x to the other side. Divide by negative 1. And whatever y is, it's the same as 3 times whatever x comes out to be. So let's figure out what x is going to be. I'm going to use the other equation, the one I did not use already. So 4x plus 3 times 3y equals 26. 4x plus 3 times 3x is 9x equals 26. 4 plus 9 is 13x. Divide by 13 is 2. Y equals 3 times 2, which is 6. X always comes first, so 2 comma 6. There it is. Reviewing the steps. I'll change to bright bubblegum pink for this. Pick your equation and your variable that's easy to get by itself. Then do that. So step 1, step 2. Once you know what that one variable equals, substitute it into the other equation, the one you haven't used yet. So this would be step 3. Once you've done that substitution, solve for your variable, plug that value into one of the original equations. So this is kind of both step 4, because I didn't split them the first time. The variable is plug it into the other equation, solve for it. Sorry if I seem to have gotten distracted there. I got kids running around and yeah, getting easily distracted. Sorry. Anyway, see you in class tomorrow.